Okay, I want to talk about finding the domain of a variable. In other words, what numbers are you allowed to plug in? Here are some things that we have to worry about. Let's look at this first example that I'm going to write out for you. Let's say I have x over x minus 3. Well, I know that everybody remembers all the way back probably from kindergarten that you guys all know you cannot have a 0 in the denominator. So for this problem, the domain of x is everything except 3. And I'm actually going to write it and describe the domain by telling you what it isn't. So I'm going to describe it in just that way. I'm not going to try to list every allowed value for x, because that could take forever, you know. It would be easier if I just use my set builder notation and I say that my domain is the set of all x such that x is not equal to 3. Because if x equals 3, it's going to make that denominator 0, and that's a bad thing. Here's another thing you have to worry about when you're dealing with the domain. Let's say I have this, square root of 2x minus 7. Hopefully you remember that we don't want negatives under square roots. Well, how can I figure out when that happens? Well, the way to figure out when that happens is to say, okay, I take 2x minus 7, and actually, you know what, let's make this problem a little more challenging. Well, no, we'll do that later. But anyhow, I take 2x minus 7, and that has to never be negative, so it must stay greater than or equal to 0. And then I solve. I get 2x greater than or equal to 7, and then divide everything by 2. I get x greater than or equal to 7/2. Okay? Let's do another one like that, and we'll make it a little bit harder like I promised we would do. So let me see if I can get these out of here, because they're kind of in the way now. So we'll shrink these. Let's see. Get out of there, you. Okay, now, well, I don't know. I could shrink them. You want me to shrink them? Or, nah, let's just get rid of them. Okay. It's kind of fun. All right, so anyhow, I want to find the domain of this variable, square root of 3 minus 5x, and then on the outside I'll put plus 8. So what's the domain of this variable? Well, the thing that throws some people is the 8 doesn't even matter. All we care about is we want to make sure that whatever is under the square root is not negative. It doesn't matter what's outside the square root. So I'm going to take 3 minus 5x, just like I did before, set it greater than or equal to 0, and we ignore the 8 for this part. Subtract 3, I get negative 5x greater than or equal to negative 3, and divide everything by negative 5. And when you do that, you flip the sign, so I get x is now less than or equal to 3/5. Okay? Let's do another type of example that's kind of a hybrid and combines the two problems, or actually I guess we've done 3 problems, but it combines the 3 problems that we've already done. Oh, by the way, one thing I wanted to say about that example we had before, where I had the x on top, and I think it had x minus 3 on the bottom. We don't care about what's on top. Just like here we don't care about what's outside the square root, we're not worried about what's on top of the fraction. You don't ever have to set that equal to 0. Like sometimes I'll give people a problem like this, x minus 2 over x minus 3, and they'll say x can't be 2 or 3. And that's not true. X can definitely be 2 if you want it to be, because we don't care if the top is 0, we just don't want the bottom to be 0. But now let's do a problem where we combine both of those things, fractions and square roots. So let me give you a problem like this, and I'm going to keep it fairly simple. Later when we get to chapter 3, we're going to do some really complicated ones. But for right now, let's just do something that's not too bad. No, I don't want to, you know what, I don't want the same number there. Let's call that 20. I don't want the same number there because you might get confused, or I might get confused. Now, for this problem, we have 2 things to worry about. Number 1, 2x minus 1 cannot be negative, because if it is, that gives us a negative inside the square root, and that's a bad thing. That's a really bad thing that we don't want to happen. Another thing, though, we don't want a 0 inside the square root, because when you square root it, the whole bottom's going to be 0, and that's also a bad thing. So for this problem, 2x minus, or 2 minus x, not only does it have to be greater than or equal to 0, it can't even equal. I said that really awkwardly, but anyhow, 2x minus x, or 2 minus x has to be just greater than 0. I can't include the equal to like I could with the other square root problem, because it can't equal 0, because it's also a denominator. So subtract 2, I get negative x greater than negative 2, and anytime I multiply or divide both sides by a negative, I flip the sign. So x is greater than 2. If you want to write this in set builder notation, your domain is the set of all x such that x less than 2. Okay? One other thing I want to point out to you as we did these problems, in the example where I had a fraction, I had like x over x minus 3 or whatever it was. In this example, I was actually telling you what the domain was not. Because to tell you what the domain was would take a long time. I can't list every number in the universe besides negative 3, because that would be really bad. I mean, maybe that could be a homework assignment for you. If you don't do your homework one night, then your punishment is you have to list every number that is okay for this x value here, but probably not. So in this problem, I told you what the domain was not, and in this problem, I'm specifically telling you what it is. So sometimes you tell me what the domain isn't, you're telling me indirectly about the domain, and sometimes you can directly tell me about the domain. Now, as we continue, we will find lots of other things that we have to worry about. When we get to the trig functions, we'll have to worry about specific values we're allowed for trig functions. For example, we'll talk about the sine and the inverse sine. And this value will have a very specific domain. We'll talk about logarithms. Logarithms are kind of nice. And inside a logarithm, whatever is inside here, that has very specific requirements. So we'll do all that stuff later on. So we haven't done everything in the world there is to do about domains. Now, one other thing I want to mention, sometimes it's not the equation itself that determines the domain or the type of operation you're doing, so much as it is the real world problem you're talking about. Like, for example, let's say I give you this equation. This is the area of a circle. Area equals pi r squared. What's the domain of R? Well, if you didn't know that this was talking about a circle, you would say R could be anything. Because, I mean, you can square any number you want. Nobody's going to come along and arrest you for squaring certain numbers. But because it's a real-world problem, we know that R can't be 0 and R can't be negative. R has to be greater than 0 because it doesn't make sense to talk about circles with a radius of 0 or negative. So sometimes the real-world problem itself determines your domain. Or let's say you're solving a story problem and your variable is P, and you want to know how many people can go on a trip, and the answer is going to be P. Well, I think you would agree with me that the domain of P is going to be positive integers. So the domain for P is the set of all numbers such that P is a positive integer. Because it doesn't make sense to talk about negative people, and it doesn't make sense to talk about fractional parts of a people. Like, I know everybody wants to get married and have 1.5 kids, but, that 0.5 kid, probably not the best situation for them. So, round up or round down, depending on the problem. And that's all I need to say about domain right now.